File of the polynomials given the roots, and notice we want real coefficients, so we shouldn't have any imaginaries. If the roots are 4, -3, and 5, then factors of this polynomial are x minus 4, x plus 3, and x plus 5. You can pick which two you want to multiply first. If I pick these two to multiply first, I'll get x squared minus x minus 12, and I have to still take that times x plus 5. That will give me x cubed, x times x, and then for x squares I'll need x squared times 5, and negative x times x will give me positive 4x squared. For x terms I'll have negative 12x and negative 5x, for negative 17x, and for my constant term I'll have negative 12 times 5, or negative 60. So this would be my polynomial given these roots. Doing that again, we know we are given we need to find a polynomial with real coefficients given these roots. Oh, if I've got an x minus 3i root, then I also have an x plus 3i root. That's automatic. If they give me one, I know that the other one's there, even if they didn't give it to me. So now my factors are x minus 5 times x minus 4 minus 3i times x minus 4 plus 3i. I'm going to multiply these two first. That will give me an x squared minus 4x and another minus 4x, so minus 8x, and then x minus x in the negative, positive 3 will give me a negative 3ix, and x minus this negative 3 give you a positive 3ix, so they're gone. And then 4 minus 3i times 4 plus 3i will give me 16 plus 9. Since negative 3i times positive 3i would be negative 9i squared, and I squared is a negative 1. So I have x squared minus 8x plus 25, and I need to take that times x minus 5. So x cubed, then I'll have a negative 5x squared and a negative 8x squared, so negative 13x squared. I have a negative 5 times negative 8x will give me 40x, and x times 25 will give me 65x, and negative 5 times positive 100 times positive 25 is negative 125. And this would be my polynomial. Now, notice here I want integer coefficients. I didn't just say real, but I want integer coefficients. And I have these fraction roots. Well, I could put x plus a 1/2 times x plus a 1/3 times x minus 1. But that's going to give me fractions. So let me think. When I factor something, I usually don't factor it into x plus 2. I usually factor into 2x, or x plus 1/2. I usually factor into 2x plus 1. And instead of having it factored to x plus 1/3, it's usually 3x plus 1 to give me that 1/3 root, and x minus 1. So these are the three polynomials I want to multiply together in this case. Multiplying the first two, I'll get 6x squared, 3x and 2x, so plus 5x plus 1. And now I need to take that times x minus 1. That will give me 6x cubed, a negative 6x squared, and a 5x squared will give me a negative 1x squared. A 5x, a negative 5x, and a positive 1 will give me a negative 4x, and 1 times negative 1 will give me negative 1. And this would be my polynomial with integer coefficients. So notice how I change these two. Now we want to find all the real and imaginary roots. So we're going to use what we know. And the factors here are 1, 1, 2, 3, 4. Which factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. So I have 1, 9, 26, and 24. I kept getting bigger. I'm going to try, believe it or not, I'm going to try this negative 3. So 1, negative 3, 6, negative 18, 8, and negative 24. I got my 0. And this is x squared plus 6x plus 8, which factors into x plus 4 times x plus 2. So x equals negative 4 and x equals negative 2. So my real roots here are negative 2, negative 3, and negative 4. 1, 3, 9, 27. However, I notice that we have an x in every term, so the first thing I'm going to do is factor out an x. That'll give me x cubed plus 9x squared plus 27x plus 27. And we already have then that x equals 0 from this one right here. Now I want to factor this. It's still 1, 3, 9, and 27. That last one was all. I'm going to try the negative 3 again. 1, 9, 27, 27. So 1, negative 3, 6, negative 18, 9, negative 27. It worked. And then I have x squared plus 6x plus 9, which is x plus 3, the quantity squared. So x will equal negative 3. So my 4 factors are 0 from this, negative 3 with a multiplicity of 3, because I have 2 times down here plus 1 here. I had it 3 times. And this would be my solution.